Okay, this video is going to be dynamic, useful. Let me share something new about me. I am biology lover with keen interest in genetics, and side by side I am data science enthusiast. Recently, I have completed 4 months data science course with Softanbees Technology Private Limited, which is one of the leading software company on international platform. On the grounds of my relentless dedication and performance, I got internship from the very company. I'm ecstatic to announce that I became the first ever Nepali student who got into the course and is interning in the very company from Nepal. So this video is entire going to be showcasing the final evaluation project regarding Shiny dashboard that added leverage in the course of getting internship to both of us. Both of us worked really hard day and night to make the Shiny dashboard ready to use, titled Analysis on COVID-19.
Hello everyone, this is Statistical Das from India. Currently I am pursuing my bachelor's degree in statistics under University of Calcutta. Having statistics as my major and passion for coding, data science is certainly a field that attracts me to the fullest. Being a data science enthusiast, I joined the training program of Softanbees Technologies Private Limited, that is Data Science with R, and successfully completed it. Right now, I have joined Softanbees as an intern for the last 1 month. During our training program, we got to work on many real-life data problems. And in our final evolution project, me and P.R.N. Yadav, my co-trainee in Softanbees, got to work together. So here in this video, we come up with the project that we work upon.
Let's just head straight into the R interface, where I'll be showing the R code, and we'll quickly jump on the Shiny dashboard where we'll view results on screen. And at last, we'll be sharing our GitHub profile.
The question set given to us, the questions being highlighted with colors were done by me, and the question highlighted with black color were done by Paulami. And actually we did it into 2 chunks because the time frame was limited, and to complete within that time frame was really challenging. But on the other hand, we really helped each other because it was impossible to do at on. So there were 2 data sets. One is COVID-19 healthy diet data set, and another one is country vaccination data set about vaccination progress of COVID-19. So let's quickly jump into the R interface. So let me share the source panel. Okay, I have maximized. So these were the library used by both of us. Now you can see the importing of the data set over here. Okay, now here you can see the data wrangling and manipulation. And yeah, this is the UI interface for Shiny dashboard. And so this was the UI part. And let me share the server part. Okay, so this is the server part. And let me highlight some important functions. And we used muted function, we used lifted function. In the same way, we use ggplot. You can see the other codes in server part. We also used auto.arima. You can see over here for forecasting, and we used ggcorplot. So this was all about the code, and just copying this local URL. Actually the thing is that this dashboard hasn't been published publicly, so for now I have to use this local URL. So let's go to the Google search engine. So let's paste it over here. Yes, now run it, and here we go. So this is the awesome dashboard, right? So the dashboard is titled Analysis on COVID-19, and this is the very first interface of the dashboard. And here you can see the progress of COVID-19 vaccination. Entire dashboard is divided into 2 chunks. One is study on country vaccination. This is one tab. Inside there are 3 mini sub items, and another tab is study on COVID-19 healthy diet. There are 2 sub tabs inside that, right? So there are 2 tabs. Let's see the first problem statement. Actually the first problem statement states that geographical distribution of the vaccines, that means which countries are distributing which vaccines and amount of people being vaccinated. Provide an interactive map view for that. So let's see the output. It is named geographical distribution of COVID-19 vaccines. So here is the map view for number of people vaccinated and name of the vaccines distributed by the countries around the world. User can just select any country from here. Okay, if I wish to select Germany, then I'll get the output in tabular format in this section, right? In the same way, we will also get the output in this map view, right? So the dark red color refers to the less amount of people vaccinated. In the similar way, the dark blue color refers to the high amount of people vaccinated. So let me maximize the map. Okay, Okay, this is the Sri Nat Geo world map, right? The format of map. And if I wish to see any of the country, right? Okay, let's see about Pakistan. Okay, if you click on the circle markers, then you'll get this pop-up info where you'll get the same result, right, which you got over in this tabular format. You'll get the same output in this pop-up info, right? You can see the name of country, vaccines distributed, and the amount of people vaccinated, amount of people fully vaccinated. Actually, it was not given provided in the data set, so it is showing any, that means not available. In the same way, you can see of any other country, right? You can see of any country like this, you can see like this, so this was all about the first part. Let's quickly jump into the second problem statement. So it was said that create a plot of daily vaccination amount according to the date, plot till the latest date that is provided in the data set. Users should be able to select the country and see the plot. So let's see the output for this. Okay, the plot of daily vaccination amount. This is the tab for the output. Okay, oh, it's looking pretty cool, right? A view of analysis done on daily vaccination amount in different countries. So user can select the name of country. Let's select Hungary. And let me share something. On y-axis it has been plotted daily vaccination amount. On x-axis it has been plotted the dates here about index. Blue line with yellow dots refers to daily vaccination on the same hand. Red line with black dots refers to daily vaccinations per million. Okay, let's see about Nepal. What's the condition of Nepal, right? Our country. Okay. Oh man, it's really disappointing, right? Because the vaccination status in Nepal is not good. Okay, let's see about some other countries like United States. Oh, amazing. So this was the output for the second problem statement.
Problem number 1.3 says that according to the current rate of daily vaccination, predict how many will be vaccinated in total till March 30, 2021. Here the user get to choose any one of the countries. Suppose I choose Albania. Okay, so from here the user gets to know a pictorial representation of how the data set will look if we plot it in a graph. So here it shows a time series plot between daily vaccinations and the date. So from here also the summary of the data set can be well known. One more feature that this R interface provides is the user can select any particular date from here. Suppose I choose April 5. Okay, so if user selects any particular date to see the forecast plot till that date, so from this user can also get the overview that how the data will look after forecasting. So another tab that is present in this interface is this blue one. This shows that predicted value for the total vaccinated till March 30, 2021. Suppose let's look into the data set for Nepal. Okay, coming to the data set of Nepal. Okay, yes, it also shows the count of the number of people that are vaccinated till date. So certainly this page will help the higher authorities and government to know means how many will be vaccinated till of March or till the end of April. This is all about this page.
So jump into the next tab, that is study on COVID-19 healthy diet. It is titled COVID-19 healthy diet. So let's jump into the problem statement at first. So in the diet for COVID tab, first problem statement was show the features that are correlated with confirmed cases both in table and correlation plot. So let's see that. So here is the correlation analysis. Actually the correlation is the term for knowing the correlation between the two different variables, right? Finding features that are correlated with confirmed cases. So here is the entire input part. User can select input. Here are the three different tables from where they will get the correlation coefficient value for selected feature. Actually feature here refers to the food items from different diet. If I wish select any one feature from protein diet, if I wish to select cereals excluding beer, then you can see here the output. It is showing the negative correlation, right? In the same way from fat diet, user can select anything, right? Stimulants. So here you can see the data. It is showing 48%, right? 0.48 correlation coefficient. Let's select any other thing as well. This you can see, and let me share one super secret, right? Where it is. Okay, it is confirmed case. It is showing 1, that means 100% correlation. Actually the the input you have selected is confirmed cases, and it is showing correlation with confirmed cases. So correlation with the same thing, same variable, it is always 100%. Similarly, select from food diet as well. Okay, select sugar crops. You can see this, it is changing, you can get the value. The obesity, you can get the value, right? Okay, now let's see this correlogram. It's beautiful, right? Okay, here is the correlogram. Okay, let's explain the index. Dark blue color refers to the high positive correlation. In similar way, dark orange color refers to the high negative correlation. The OFLs is not correlated, it's not having any correlation with confirmed cases. In the same way, the milk excluding water is having correlation with confirmed cases, the positive correlation. In the same way, the vegetal products is having negative correlation, high negative correlation with confirmed cases. The same way you can see the fat diet, right? From here also you can interpret the dark red color for high positive correlation, dark green color for high negative correlation. From the food diet you can get the same thing in different way, right? So from this correlogram you got to know a lot more thing, and I hope it was really interesting.
Okay, the problem set or the problem that I was assigned is give user chance to select between obesity, undernourished, confirmed and deaths, recovered and active, and show which type of foods are responsible for which. Yes, so searching which type of food are responsible for what kind of consequences. So here user get to choose between the consequences in which he or she is interested in. Suppose I want to know that confirmed cases of COVID-19 depends on which food items or not. So here this table gives the correlation between the type of food and the consequence. Let's check for any other consequence. Suppose I take undernourished. Okay, so undernourished is giving only one category, vegetable products, that has a correlation coefficient of 0.3. Lastly, how this could help others, it could help others to make their plan their diet chart accordingly, depending on the consequence that they select. Okay, but lastly, let's show you my GitHub profile where you people can search with an username of daspaulomi30. So thanks a lot.
In the very beginning, I was from biology background and non-coding background. I got to know that data science is important in my career as part of my interest. So I kick-started my career of data science with Softanbees. And throughout the training program, just 4 months, I got to know a lot more things. See, I was at the 0 position, and now you can see where I am. And I want to add one more thing, that see guys, being from biology background, how I integrated the knowledge of my data science in the field of biology. User can get a lot more information from here, right? The user can be benefited in several ways. They can get the pictorial analysis from this shiny dashboard, and in the same way they can also get the visualization and analysis on COVID-19 healthy diet, so they can also know which food items are responsible for the confirmed cases, for deaths as well, for different other disease and related with the confirmed cases. And so they can drop that diet from their balanced diet, and they can just add different new food items in their diet. So in this way the people can be benefited. We created an impact and effectiveness in the society with this shiny dashboard, and hope this shiny dashboard will be really published very soon publicly. So that's all about the shiny dashboard. Okay, this is my GitHub profile, you can follow me over here. In this video I was just able to explain everything in nutshell. If you wish to analyze, visualize in detailed way, then you can just quickly follow me in the GitHub, and you can just import download the datasets and app.r file from here, and you can just continue.
Hope you have got some idea on what level of data science projects we are given to work upon. It was a really interesting tenure to solve the problems and draw some meaningful conclusions out of this unstructured and collection of data sets. Before we end this video, we both want to thank Softanbees Technologies Private Limited to give a kickstart to our career in data science field, which was really incredible.
Let me know this video was useful for you guys. Drop your view in the comment section below, and thank you so much for watching this video. Don't forget to subscribe. See you soon. Till then, stay healthy, stay active. Thank you.